Hi, we're Team Optima, and my name is Santiago.
I'm Jesse.
Cindy.
And I'm Joshua.
And our project is Telecap. It's a smart construction helmet.
Okay, so our design is trying to address two needs, safety and communication. With the IntelliCap, we're hoping we can increase productivity and safety in the work environment. Our proposed solution. Our IntelliCap will have a camera and SD to record and store videos, GPS for time management, Wi-Fi and Bluetooth for improved communication, accelerometer to detect large falls, and LEDs to toggle on and off when needed. A GUI for managers to assign tasks, sensors to detect when the helmet is being worn, and lastly, a rechargeable battery. Alright, so we had 4 designs at first. We had video surveillance software, a motion-based music player, a home automation system, a car security system. But with all that, we ended up going with our design, the IntelliCap. With our major components, we have a Raspberry Pi, a camera, a GPS, iPhone amplifier, microphone, speaker LEDs, ADC, light sensor, accelerometer, pressure sensor. Our design constraints. A camera to record pictures, GPS for time management, Wi-Fi connection for communication with the internet, Bluetooth for increased communication with wearable devices, speaker and microphone to output and input audio for enhanced communication, SD card to record data, accelerometer to detect large falls, LEDs to blink when a large fall is detected, buttons for volume control, sensors to detect when the helmet is worn. A GUI were managed to increase necessary information, input and assign tasks, and display the tasks assigned. A rechargeable battery to increase the battery life. A helmet made with HDPE, interface with external device like a watch or phone application. Test for weight and how the battery and other components will be added will react with user set.
So the product requirements, it must maintain the primary concern of protecting a skull, and it must be easy to operate, probably visible, and it must we're gonna have an emergency button so they'll be able to toggle help if whenever they wanted to. The product must be comfortable enough to wear for long periods of time, so at least an 8-hour day. And we want it to be a little stylish, where it looks like a piece of high-tech equipment, but not look too futuristic. And we want it to look classic. So here's our software function, or software block diagram. So where it's going to start is whenever the worker's going to put on the helmet, it's going to trigger the GPS to search for position and time, and it's going to basically stamp the clocking in aspect of going to a job site. And so GPS, once it's triggered, GPS searches and stamps the time, and then sends the information as a document, text document, and it's going to connect. Well, in the meantime, it's going to have a connection to Wi-Fi, so it's going to send that information through the internet. And we are going to have sensors to detect light. So when the ambient light is detected, it's going to lights are going to be off. But once there's a lack of light, the LEDs are going to kick on. We're also going to have the accelerometer. So when the accelerometer detects a large inertia, falling, hard hit, it's going to trigger the Raspberry Pi to send alerts by sound through the speaker, as well as lights flashing. And also, like after the end of the day, when they take their helmet off, it's also going to search for GPS and stamp that time as clocking out. We're going to have some functionals. This is the hardware. So in the center is going to be the Raspberry Pi itself, and we're going to power that with a lithium, presumably a lithium polymer battery, 7.4 volts. We're going to have the on button. We're also going to have the microphone connected to the Pi itself. We're going to have volume buttons, so you can control the volume. And the GPS is going to have to get hooked up to the Pi, and that's where it's going to get power from the Pi. We're also going to have a SD card, so it can record data. and we'll have the panic button or emergency button, and we'll also have a charging port as well to recharge the batteries. That's another diagram. Proposed design process.
Okay, so this is our proposed design process. Like Santiago said, we're gonna have a battery on it, and we actually want the battery to be able to last for like 8 hours. That is pretty much our entire day's work. And we're gonna be using the Raspberry Pi, so I think this was a touch screen. Okay, so we're gonna be using the Raspberry Pi and Raspberry Pi Zero. So we're gonna have the GPS connected to it. We're gonna have the accelerometer and all the stuff connected to it. And we're using the Raspberry Pi because it's really light. It's about 90 grams, so it's very, very light. It's not heavy, guys. It's not heavy at all. And then the LED also is going to connect to that. So the design process, like he said, clocking in and clocking out. That's one big thing for us. And the GPS is going to do that. The GPS would sit on the board as well. So the GPS is going to be connected to the Raspberry Pi. And when you put on the helmet, it's going to stamp the time, stamp the location as well. So they're held accountable. And the LED is also going to be incorporated with it, with the GPS as well. So, and then for detecting falls, this is where the accelerometer comes in. We're going to have an accelerometer on it, so when they fall, we'll do it in such a way that, workers, they could be careless, they could just throw it on the floor, and we don't want that. So we're going to do it in such a way that there's a certain height to which it's going to fall from, and when it falls from that height, then we will pretty much know, okay, there's a problem somewhere. And when that happens, light is going to flash, the sound is going to go off, and with the app we're going to be making as well, the manager will be alerted to know that this is what is going on, so they can quickly get to the worker that's having the issues. Then communication, that's another big part. So in general, we're actually handling 3 things with this project. One of them is location, the other one is the falls, which is for safety, and communication. So communication, the speakers, microphones and the speakers, the workers and the managers, they can communicate and talk. Workers can talk to each other as well. Like we said the other day, construction is really boring. So, if they have the microphone on there, they can pretty much talk to their co-workers. And all of them will also looking into their privacy issues as well. So privacy is not compromised. For cameras, we're going to put a camera on there as well. So if a worker is having any issues or any stuff like that, they could pretty much just turn on the camera and call the manager and be like, hey, this is what I'm having, or this is the issue I'm having. What do you think about it? How do I go about it? That's the major part of the camera. And it's going to have an SD card as well. It's going to have an SD card as well to record data. So they might want to take pictures, record a little bit of videos. So that's where the SD card comes in. So the manager will be able to see the graphic user interface. And this is the budget. It is not very expensive. This is an inexpensive project. The main thing taking a lot of money from here, it's the Raspberry Pi is $14, which is a little bit cheap. The light sensors, $15, and the main thing is the GPS, which is $40. Everything comes out to $167. You can't beat that price for a project, for a smart helmet. Yeah, so I'll hand over to Cindy.
The first task that we want to complete is getting workers to check in and out without them, automatically without them having to go into their manager and call. So something we're going to do first is the GPS, putting the GPS onto the board, and then just make sure that the GPS is able to specify the location, and we'd have to specify a specific location, when you're on the construction site, that's the location we want you to specify. And so after we've done that, that's going to be a code for that. After we've done that, we would want to have a pressure sensor so that it knows whenever the element is on the walker's head, and so then it can check them in or check them out whenever they take it off. And then the next thing we're trying to do is detect falls. And so the way we're going to do that is using the accelerometer, but then we're also going to have to incorporate that with LEDs so they can blink in off and on whenever a large fall is detected. And then the last one is enhanced communication. And this depends on if we're able to get to it. It's not a priority for us. But if we're able to get to it, we're going to try to increase communication on the construction side between the managers and the workers. And basically, it's going to help out with like productivity and efficiency on the construction side. And then lastly, we want to like test it out and see if everything is like working well with each other. And so something we want to do is like test the battery or like the battery life and see if it actually does last for like a full day's work. And then we'd also want to like maybe incorporate it and put it on someone who's actually working on the construction site and see if it's not like uncomfortable for them to like wear that for like a long period of time, you know, just to see like how it's like working in terms of like real life, you know. And then the schedule, which the plan is to like start in like June, sometime in June, and then end in October. So the one that's going to take the longest time is going to be the stage one, which is getting the workers to clock in and out. Everything else shouldn't take that long, and we have like enough like breaks in between to like not feel stressed. So something that we were like planning for this is to, we have like specific numbers of days like finished stuff, and we also have like breaks in between each stage. So in case we're not able to get a stage done at a specific time, we still have like a follow-up time where we can still complete it because there's like a break. Because like for example, stage one ends in like August, but we don't start. We just started in August, but we have like 2 days break, so that's a good time to like maybe work at stuff that we're not able to like finish during the assigned daytime. So I feel like this schedule would work because we'll be able to, because we have like gaps in between each stages that if we're not able to like finish each stage at a specific time, we can still get it done in the time that we have allotted for like resting. I don't know if that makes sense. But yeah, so conclusion.
Conclusion, we believe that after we successfully complete all the tasks that we plan out to do, that it can actually be a product that can go out to the real world and improve the workplace in general. So we're pretty excited about finishing this project and getting started learning. Thank you.